Today on Capechi's Corner, we're going to look at solving radical equations and inequalities. So we do have some steps that we can follow, and this will hopefully help you through the process. The first thing, anytime we're dealing with radicals and we want to get rid of them, we need to isolate the radical on one side. From there, we're going to eliminate the radical sign by raising both sides to the needed power. So if it's the square root, we're going to square both sides. If it's the third root, we're going to take both sides to the third power. Then we always have to make sure that we check back into the original equation, and that is because we're checking for extraneous solutions. Now, you see extraneous solutions a lot throughout your math career. Remember, they're a solution that when you solve it, it works. It's not that you made a mistake, it works. But when you substitute it back into the original equation, you do not get a true statement. So let's check it out. All right, number one, again, here's my wall. I want to isolate my radical sign, so I'm going to bring 4 to the other side. And I have the square root of x plus 2 equals 3. Now, again, I need to get rid of that radical sign, so I'm going to square both sides. And I have x plus 2 is equal to 9, so x is equal to 7. Now, I'm going to check it by substituting it back into the original. So I have the square root of 7 plus 2 plus 4 is equal to 7. So we know the square root of 9 is 3 plus 4 is equal to 7. So that's true. So x equals 7 is my final answer. Okay, looking at our next problem, there's my wall. Now I have a radical on both sides. So I need to get rid of that radical, so I'm going to square both sides. So on the left-hand side, I get x minus 12. Now on the right-hand side, by squaring that binomial, I'm really asking you to do this, right? So we're going to use FOIL. 2 times 2 gives me 4. My outside is negative 2 root x. My inside is negative 2 root x. And my last is going to give me plus x. Next step, I'm going to combine my like terms. Now, if I subtract x from either side, they're going to zero out. Okay, so now I'm trying to isolate this radical right here. So I'm going to bring negative 4 to the other side, and I have negative 16 is equal to negative 4 root x. Now, again, I'm trying to isolate that radical sign the best I can. So I'm going to divide both sides by negative 4. So I have 4 is equal to the square root of x. And again, if I square both sides, I have 16 is equal to x. Okay, let's substitute it back into the original. So my check will be right here. So I have the square root of 16 minus 12 is equal to 2 minus the square root of 16. Well, 16 minus 12 gives me the square root of 4, which is 2. On the other side, I have 2 minus 4, which gives me negative 2, which is not true. So what happens is this right here is an extraneous solution, which again means that we solved it and we got a 16. There wasn't a mistake along the way, but when we substitute it back into our original, it does not satisfy the equation. So really the final answer there is no solution. No number we put in there is going to work. All right, let's take a look at our next problem. Now, in number 3, very similar to the last one, except for I have my radicals on the same side, so I don't want that. I'm not going to be able to get rid of a radical sign that way because my radicands are not the same. So I'm going to bring that to the other side, and I have the square root of b minus 6 is equal to 3 minus the square root of b. Now we'll do what we did last time, and I'm going to square both sides. So I have b minus 6 is equal to, now again, I have 3 minus root b times 3 minus root b. So when I use FOIL, I get 9 minus 3 root b minus 3 root b, and my last term there is going to be plus 2. I'm sorry, plus b. Simplify what I can, combine my like terms. This should be b. Now again, if I subtract my b's, they're going to zero out. I'm going to bring that 9 to the other side. And I have negative 15 is equal to negative 6 times the square root of b. Divide both sides by negative 6. And that simplifies to 5 over 2 equals the square root of b. So again, let's square both sides. And I have 25 over 4. Now, this is a little difficult to check, but we can. I just use your calculator, right? So when we check it, always go back to the very beginning, our original. So I have 25 over 4 minus 6 is equal to the square root of 25 over 4, and that equals 3. Oh, sorry, I have a symbol wrong there. That's a plus. Okay, so once you do that and you put that in your calculator, it is going to work. So 25 over 4 is the solution, and that's what the value of b is. Okay, so let's take a look at our next one. We now are working with the third root. Okay, so again, here's my wall. Remember, I want to try to isolate my variables, my radical, so I'm going to bring that to the other side. So I have 2 times 6x minus 3 raised to the third power equals 4. Divide both sides by 2. And I have 6x minus 3 raised to the 1/3 power is equal to 2. Okay, so and again, you could also write this like this if this helps you. It's really just a personal preference. You have to decide which way works for you. Now, I want it to the first power. So how that works is I'm going to raise this to the third power. And I'm going to raise this side to the third power. Now, how do I know? Because 1/3 times 3 gives me 1, and that's what I want. Okay, so then I have 6x minus 3 gives me 8. So 6x equals 11. Divide both sides by 6, and x is equal to 11 over 6. Now, again, you're going to substitute that back in to check it. Remember, we're always checking for an extraneous solution. So I have 6 times 11 over 6 minus 3 raised to the 1/3 power minus 4 is equal to 0. So this gives me 2. This simplifies to 11. 11 minus 3 to the 1/3 power. So remember, this is, we write this like this, right? This is like the third power of 8, right? If that helps you. Again, just trying to show you some options. 2 times 2 minus 4 gives us 0, so I'm all set. X is equal to 11 over 6. Okay, so that's it for some equations. We're going to do some radicals with inequalities. So similar, there are some steps that are easy to follow. Solve the inequality, but we have to talk about what are the limits. And that, remember, is the radicand has to be greater than or equal to 0. Okay, so that's what this is right here. That's the limits we're looking at. And then you're going to state solution by looking at, you're going to have 2 sets of limits, which you'll see once we get started. Okay, let's take a look at our first problem. And just so we don't forget, I'm going to take that radicand and I'm going to make it greater than or equal to 0. So if 5x is greater than or equal to 10, x is greater than or equal to 2, and that is my first limit that I have to look at. So now let's solve it and let's see what else happens. Similar to what we did with equations, we have to isolate. So I'm going to bring that 3 to the other side. And I have the square root of 5x minus 10 is less than or equal to 5. To get rid of my radical sign, I'm going to square both sides. I have 5x minus 10 is less than or equal to 25. Add 10 to both sides. And I have 5x is less than or equal to 35. So x is less than or equal to 7. Okay, so that's our other limit. So if x has to be, remember, somewhere on a number line, right? I always say when I was a kid, I never liked the number line, but now that I'm a teacher, I can see that the number line really does kind of make sense. It's such a great visual for students, especially those that really kind of need to see it. So if I'm talking about numbers that are less than or equal to 7, they're going to go this way. If I'm talking about numbers that are greater than or equal to 2, we're going this way. So you can see kind of the overlapping pieces in between, because x has to be greater than or equal to 2 and also less than or equal to 7. So that's going to be your final compound inequality statement that's going to work. Those values within that parameter will work in giving us a true statement for number 5. All right, let's look at number 6, our last one. Same idea holds true. First, I'm going to start with what my limits are. So I have 2x plus 2 has to be greater than or equal to 0. So 2x is greater than or equal to -2. So x is going to be greater than or equal to -1. So that's our first one. I like to do that first just so I don't forget. And number 6, again, I'm going to bring that -1 to the other side. I have the square root of 2x plus 2 is equal to 4. Get rid of my radical sign, I square it. So I have 2x plus 2. Oh, forgot that. That's greater than or equal to 4 squared is 16. Bring that 2 to the other side. 2x is greater than or equal to 14. Divide both sides by 2, and x is greater than or equal to 7. Okay, so now again, that's our other parameter. So we have to kind of figure out what's going on here. So if I have 0 here, -1's here, 7's up here somewhere, I'm looking for values that are greater than or equal to -1 and also have to be greater than or equal to -7. So again, that's kind of going from there. So I can't have something that accommodates both in a compound inequality statement similar to what we did before. So if they have to be both, in the end, kind of the final answer is they have to be greater than or equal to 7. That's the only way they can also be greater than or equal to -1. Okay, great job today. Thank you so much for stopping by, and you have a great day.